Hello everyone. Today we are going to learn how to balance chemical equation of oxidation and reduction reaction happening in a basic medium. Please stay with me and welcome to Nash Education. In the following example, we have an oxidation and reduction reaction happening in a basic medium, and we need to balance the equation of this reaction. First of all, we are going to divide the equation into two halves. So my first half will be in between MnO4 minus 2 and MnO2. And my second half will be in between C2O4 minus 2 and CO2. I will start with balancing MnO4 minus giving MnO2, so MnO4 minus 2 producing MnO2. And the first step is to balance any element available in your equation other than the oxygen or the hydrogen. So I can see Mn and Mn in both sides are equal and they don't need to be balanced because they are already balanced. Second step is to balance any oxygen available in your equation by adding number of water molecules to the side that has less oxygens. So I can see here I have 4 oxygens, while on my other side I have only 2 oxygen atoms. So my right side is the side that has less or lower number of oxygens, and therefore I will add 2 molecules of water. Every 1 molecule of water is providing us with 1 oxygen atom. So 2 oxygen atoms here, and we have already another 2. That will give me total of 4 oxygen atoms in both sides. At the moment we added oxygen by adding water molecule, we will find the number of hydrogen atoms are going to be created. So now we have 4 hydrogen atoms on my right side, and that needs to be balanced. So I'm going to add protons as He plus equal to 4 protons on my left side. So now I'm having 4 hydrogen in both sides. Because this reaction is running in a basic medium, therefore I will add immediately 4 OH minus also into both sides. So the number of OH minus must be equal to the number of protons, and that number needs to be added equally in both sides so not to break the balancing. Any 4 H plus and 4 OH minus in this case means I added 4 H2O molecules. So my equation will become MnO4 minus 2 plus 4 H2O will produce MnO2 plus 2 H2O plus 4 OH minus. We can see here we have 2 H2O in our product side and we have 4 H2O in our reactant side. That will be simplified by doing 4 minus 2. So the 2 molecules of water will be removed while I will have only 2 H2O in my reactant side. So my equation will become MnO4 minus 2 plus 2 H2O will produce MnO2 plus 4 OH minus. So we can see now all elements are completely balanced. I have 1 Mn in both sides. I have 4 hydrogens in both sides, and I have 2 oxygen here and 4 oxygen there. So this is total of 6 oxygens in both sides. So the only thing left here is to balance the charge. MnO4 has -2 charge, water has 0 charge, so altogether on my left side will give -2 charge. MnO2 has 0 charge, hydroxide has -1 charge, but because I have 4 hydroxides, so 4 times -1, that will give me a net charge in my product side equals to -4. So the side that is less negative or more positive is my reactant side. That is why I will need to make this side also balanced in charge to the opposite side. So I will need to add 2 electrons. So -2 because of the 2 electrons plus -2 will give me -4, which is equal to the opposite side. So my half reaction after balancing is 2 electrons plus MnO4 minus 2 plus 2H2O will produce MnO2 plus 4 of OH minus. Again, I repeat, all of my elements are completely balanced as well as my charge. I can see my electrons are available now in my reactant side. So this is the side of my reactants. And that means electrons are used in this reaction. Any use of electrons or gain of electrons means my reaction here is doing reduction. So we will call this half reduction, half reaction. I will follow the same steps of balancing the other half. Please stay with me for a few minutes and I will be back to show what will be my net oxidation. So now we are with the 2 balanced half equations and we need to find the overall equation of both oxidation and reduction reactions. First thing we need to check is the number of electrons gained and lost in each step. We need to keep in mind the number of electrons transferred have to be equal. So I can see 2 electrons are gained in my reduction step and 2 electrons are lost in my oxidation step. So these 2 electrons are going to cancel each other. If they are not equal, then I will need to multiply my full equation by a number that will make the electrons to be equal in both sides. Now I will add the remaining of each equation in my reactant side and in my product side. So in my reactant side, I will see MnO4 minus 2 plus 2H2O plus C2O4 minus 2. In my product side, I have MnO2 plus 4OH minus plus 2 of CO2. To check the balancing, I need to check first my number of element or atoms of each element in both sides. So I can see I have 1 Mn and 1 Mn in both sides. For the hydrogens, I can see I have 4 hydrogens in both sides. For the carbons, I can see I have 2 carbons in both sides. And finally, for the oxygens, so 2 times 1 here, that will give me 2 oxygens. And then I can see another 4 and 4, so that will give 10 oxygen atoms in both sides, because in my other side has 4, and here we have times also 2 times 2, this is 4, and we have another 2, so 2, 4, and 4, that will give me 10. Now I reached to find if my net charge is equal in each half. So the net charge on my left side is equal to -4. -2 here and -2 there, so that will give me -4. And my net charge on my right side is also equal to -4, because 4 times -1, so each hydroxide has -1 charge, that will give me a total of -4. So my elements are completely balanced, my charge is completely balanced, so that is how I can get a balanced oxidation and reduction equation that is happening in a basic medium. Follow my videos to find how we can balance oxidation and reduction reaction in an acidic medium. Goodbye, everyone.